First thing first, happy Halloween. Welcome to Modular Hippo, the channel where I'm trying to build a 36-foot aluminium blue water sailboat. In this episode 17 of the components build, I am looking at the Victron SMartShunt and I am connecting that for the first time. I'm also printing some covers for the Victron SMartShunt and for the Lynx Distributor as well, among other things. So let's take a look. The 70mm cables have arrived, the ones that can handle 485 amps. So I am going to replace the old cables that is now connected to the motor, which was only 35mm too, which is roughly 240 I think amps. Just in case, because these are two 10 kilowatt motors, so they can produce around 400 amps in the worst case scenario. So let's replace those. I have now replaced the thinner cable with the 70mm cable on both sides. So that now goes into the Lynx Distributor. As I have a 300 amp fuse in the distributor, I do no longer need these additional fuses that I previously had up here. So I have removed those because it's a bit overkill. In theory, we should be able to fire up the motor now and use the motor connected to the Lynx Distributor. Let's give it a go. With the battery powered up, I just need to open these. So I'll put those to on, and then I think I must have turned the electricity off or the power off from the motor last time with the on button on, because the motor went on straight away. So that works fantastic. So that's interesting. The lever is almost flat out, which means that the RPM must almost be its full RPM. Either way, it works and it allows me to start to do some further testing with the motor. As mentioned in the previous episode, I am going to print a cover for this SMartShunt. So luckily someone has designed one before me that is shared, so that's nice. See if I can put the credits in here somewhere. So it's just a plastic lid that goes on top of here, just to kind of make sure that you don't short at these 2 points here. I'm also making 2 versions, or printing 2 versions of these 2 open points here, because you can very easily bridge these and that wouldn't be good. So let's 3D print and see how it comes out. I haven't used a 3D printer for a while, so it asks me for a firmware update. So let's do it. So this might take a while, so... So we're back in business. I got some blue filament, which should be fairly close to the Victron blue. I can see it's a bit of a difference here, but it's hopefully close enough to look okay. New spool ready for load. A little bit of Bambu Lab adhesive, make sure that it doesn't stick. So an hour and 6 minutes, and then hopefully we should have something like that for the SMartShunt. And we have something like this. Let's see if it fits. We have some cables at the bottom here that looks like they're a little bit in the way, but I think I can just cut out a little bit of the plastic down there, and then this one should slip on fine. So Once again, it gives me a little bit less of a worry that I'm going to bridge those two. So let's modify those. Starting the print of the next covers for the Lynx. And we have these spots. So let's see. Looking good. And this one. A little bit of support material there. Because of the rounded corners. So yeah, let's see how they fit. So let's see. That is a little bit better than before. It's not so easy to accidentally bridge those two. So let's try the top one as well. It looks like my bolt is a little bit wider than what this one is designed for. So I'm probably gonna just remove maybe a spacer on the left side, or we can look at that later. I have received my cable, so it is a VE direct cable that I'm going to use for my Victron SMartShunt, and I've seen that people mount the smart mount straight onto the negative here, which will save me to create another cable for it. So I'm going to do the same thing. So I'm going to move this one down to here, and I think the positive then also goes to positive, and then we can use this cable to connect it to the Cerbo, and I should be able to see things on the screen here, as well as I should be able to download the Victron app and use that for monitoring the voltage and the current going in and out of the Seplos pack. So let's give it a go. So we now have the Smart Shunt in place. So we have battery miners going to the battery pack. We have the load miners, which connects to the Lynx Distributor, where all the loads are connected to. And we have the positive cable coming from the Smart Shunt going to the positive. And we have the negative. There is no negative, because the negative is built in. So what we have is the VE cable that now goes up to the VE port on the Victron. And we also have an AUX cable, which can be used in different setups. If anyone knows, I haven't read up on the AUX cable, but if anyone knows how I can use this to my benefit, I will have multiple batteries, then let me know in the comments. For now, I'm just gonna let it hang free. So let's fire this up and see what happens. So we have the battery on, and we switch down here as well as here. That should send power to the Smart Shunt. So it is indicating that it got power. So it's a blue USB, or not USB, Bluetooth light blinking. There's no errors, which is good. The Cerbo GX has fired up, and oh, there we go. So that's open. So it's a Smart Shunt IP65 500 amps, so that's mine. It says 100%, which is not a 53.7 volts, and that's probably the draw, 0.1 amp, which is probably the Cerbo GX itself and the screen. So probably need to calibrate the state of charge so it matches up with the state of charge of the actual battery itself. And yeah, I need to read up on the configuration of how to set the state of charge, but so far it looks good. I guess that we can do a quick little test by starting the motor and see what happens when I put a bit of load on. Okay, so we're up in 9 amp, 9.7, that's the watts, 565, 10.7, yeah, so we got ice. Hopefully you can see, but my Smart Shunt is now showing up in my Samsung phone. So if we click on that one, it's connecting and it wants a pin number. So let's try 0000000 and pair. Unsecured access. Do not bore me, not now. Okay, don't leave the app while updating progress, stay close to the device. Update, so it's doing something. So I'm updating from current version 4.10 to new version 4.16. So I guess that's the firmware update for the actual Smart Shunt hardware itself. So I will let this run. So it's now updated and we'll continue. And I guess we can now go in and have a look at the Smart Shunt. It's connecting and ta-da! So we have voltage 53.14, the current is 0.16 amp, which is interesting because it says 0.2 amp on the actual screen up here. So I want to know why it is a difference, but we can figure that out. And we have time remaining and it has trends and history and that one. And what does that one want? Updates available, so updates, so version 52, so I'll update that. So firmware updated to version 2.52, and we can go back to the Smart Shunt, connecting. So we have a current of, so instant readouts, enable. So current is 0.15, which is different from, it could be that the Smart Shunt only shows 1 decimal, as this one is showing 3 decimals. So that can probably be set in the Cerbo. So yeah, let's see what that is. First setup, below parameters, okay. So this is where I can set the aux input and the battery capacity. So I'm going to stop here because I want to read up on this before I make any settings. Hooray, we have received the VE cable, the RG45 comms cable that goes between the Cerbo GX and the Victron MultiPlus. So we should be able to make sure that they speak to each other. So let's put that in place. With the cover off, we have 2 VE bus ports up there, which I think I can just pick any of them. Not 100% sure why there's 2 VE bus ports. But I'll find out, so we'll just use one of them for now. So we have that in place there with a little rubber grommet. And on the Cerbo side, it goes into the VE bus port. I think the VE CAN ports are for other connection points, like, for example, the Lynx and some other Victron products. So in theory, we should be able to switch this on, and if we switch the light on, maybe we can see something on the screen. Let's see. Okay, so we have something we didn't have before. We can see that there is an AC load of 28 watts, which is interesting. And I guess that is as much as we will get, because that is basically the inverter, the MultiPlus, showing the AC outgoing load. And this will be the AC incoming load when I have it connected to the shore power, I suspect. So I think we have the ice that we need so far. So that's good. Okay, I'll put the set the battery capacity to 314 amps because that's what the Seplos Mason 280 pack is. And when I get a second battery box in place, I will then have to increase that to 628. So the readings here is what the system is using when it's calculating how much power you have left or are consuming, or how many minutes you have left of a certain load. All the others are more or less left as they are. So charge voltage 57, potentially that could be a bit lower. Discharge flow 20, tail current 2.8, which is 1% I think of the battery. Surge detection time 3 minutes, and that is the number of minutes that it collects data before it gives you an average output. Q-cut exponent 1.1, change excitation factor 98%. So if anything of this looks worrying, or if you have any experience with some of these values, feel free to let me know. The next thing I need to do is make sure that I charge the battery up to 100%, because right now I have a reading of 100% here. So what I want to do is set it to 100% when the battery actually is 100%, and then I can start to count downwards from that point. At that point I probably want to get the battery down to 80%, because it's not good to keep the lithium iron phosphate batteries at 100% at all times. So if you are literally just using it now and then somewhere between 80 and 20% is recommended. If you then, for example, want to go on a long journey and you want to kind of top it up, then it's not a problem to actually top it up to 100%. But if not, and just for daily use, try to keep it under 80%, and that is for longevity. Just as a trial, I have plugged in the AC in to the inverter just to see what happens here. I can see that the isolation transformer indicates that we have power, but we have nothing in the top left corner here, which I assume is that because we haven't set the Victron MultiPlus to actually charge the battery, it's not actually drawing anything from the AC at the moment. So it's either that or some other setting. So what I'm going to do, I'm going to read up on that, and we're going to see if we can get a value in the top left corner as well of anything AC coming into the inverter. It is getting quite cold here in the workshop. I don't have the heating, so the last thing I'm going to do is connect the EG4 to the Lynx Distributor. So I am going to make sure it's connected. It's really important that when you charge the battery, you don't have charges coming in from two separate sources. So right now I have the EG4 and I also have the MultiPlus. So at some point I need to probably put a three-way switch somewhere to make sure I will never charge them at the same time. I don't think that should be the case, because I either use the MultiPlus because I have short power, or I will be using the EG4 because I'm using the generators. But it's definitely food for thought. With the EG4 charge inverter connected to the Lynx, I just need to figure out what amperage I need on the fuse that will be sitting here. Although it's not energy or power going out, I can still have a short on the EG4, so I need to make sure there's at least something here. I had a valid comment asking me if I had pre-charged the MultiPlus-II before I connected it to the battery, and that was news to me. I don't know what pre-charging is, but apparently there can be a bit of a surge when you initially connect the battery. So if you don't pre-charge it, you can then damage the MultiPlus, or you can then damage the battery, or even different connection points. So it's running fine, and I contacted Seplos themselves and I explained the situation, and they said that I do not need to pre-charge this one, and the same thing came from the company that I bought the MultiPlus-II. So I'm not saying that's the right answer, it's just the answer I got. So if you feel that you need to pre-charge your units before you start them, then read up on it and see if it's needed. Thank you for watching this episode and for following the build in general. If you're new to the channel and you want to see more, then feel free to subscribe, and please know that there is a separate playlist for the actual motor build, the electrical motor build, as well as the boat build. If you have any concerns, any comments, any advice, anything you want to share, please stick it in the comments and I will respond within 24 hours. Happy Halloween, and I'll see you next time.